I'm Tim Ventura, and we're joined today by Gary Stephenson, an aerospace systems engineer with wide-ranging industry experience at organizations including NASA, United Technologies, Lindquist, Boeing, ITT, and Hughes Aircraft Company. Gary's had a deep interest in gravity modification and advanced propulsion for decades and has published numerous scientific articles on various topics, especially related to the detection and generation of high-frequency gravitational waves. Gary is also a well-established contributor to many authoritative scientific papers by other researchers and is a past participant in notable advanced propulsion conferences such as the 2003 Mitre High-Frequency Gravitational Wave Conference and the 2005 to 2008 ISNPS STAIF Section F Conference events. So Gary, welcome, sir. It is an honor to have you with me, and I am overjoyed.
I appreciate the chance to have a chat with you, as always.
Absolutely. The reason I am overjoyed, as I was mentioning before before we started, so you and myself, but you absolutely have been part of superconductor gravity modification research in one way or another, going back well over 20 years.
We've both been following this for a long time. That's right. Yeah.
Yeah. One of the things that I'm finding is we have a new generation of young minds who are getting into this area who aren't familiar with the history. And so one of the things I've been doing is going back through key events, trying to put those all, together. So the story, I guess, what brought this back into the headlines was Dr. Ning Li was covered by a fellow named Noah Logan, writing for the Huntsville Business Journal. He did an article on her, and he was talking about some of the mystery surrounding her later years, as well as some of the events surrounding, her rise to fame, I guess, in a sense. So I guess I should start out by saying, do you remember much about Ning Li?
I only met her once at the first High-Frequency Gravitational Wave Conference at Mitre in McLean, Virginia, and that would have been 2003. So I did see her present at that time.
Okay.
But I didn't stay in touch with her, and I've never collaborated with her.
Well, this story, as you well know, this story is much, much larger and more expansive than just Ning Li. I mean, there are dozens of PhD physicists as well as experimenters, NASA folks. So many people have been involved in this at a deep level, including yourself. But I did want to start with her because I think that is kind of where this story begins. Dr. Ning Li and I believe Douglas Torr co-authored The Effects of a Gravitomagnetic Field on Pure Superconductors back in 1991. This was co-authored in Physics Review D, Volume 43. So there was research by Dr. Robert Forward and others before this, but that's where superconductors come into the picture, right?
Yeah, that's right. Doug Torr was, I believe that Ning Li was his advisor. And he was getting his PhD. And so he wrote on coherent zero-point motion, how the coherent zero-point motion inside of superconductors might be leveraged to create gravitomagnetic effects. This idea had been around for a while. Physics is this continuous stream of ideas.
Yeah.
And so Andrei Sakharov had first conceived that gravity might be coming from some interaction with the zero-point motion. And that was in the 60s. And then Hal Puthoff did a lot to build on that. And so the stream of potentially leveraging coherent zero-point motion, which happens in superconductors, really originated with Sakharov and then Puthoff. And then I think Torr picked it up from there, working with Ning Li. And so that's what led to their paper in Physics Review D that described a potential method of creating a gravomagnetic effect with this coherent zero-point motion.
Okay. And so Ning Li's paper, it did get some attention, it did get some traction, but the media frenzy started in 1996. And this is kind of more to the historical backstory of things. In 96, Dr. Eugene Podkletnov attempted to publish a paper on superconductors and gravity control. So his paper was about an experiment back in 1992. And if I remember correctly, he had a 12-inch rotating superconductor, so a very large disk at several thousand RPM. He was doing materials analysis, structural integrity testing on this thing. And from what I recall, pipe tobacco from a colleague of his started rising in a column above this, and they felt that that was a reduced gravity effect after some investigation. And they had talked about going to various floors in that building above the superconductor, and they apparently detected what they felt was this same effect going up. So they called this gravitational shielding, right?
Yeah, I wasn't familiar with that story. I did read some of his papers over the years, but I always wondered what prompted him to think that there was reduced gravity. Certainly, if you're seeing effects in other rooms, then that tends to indicate it's not just a thermal effect.
Yeah.
It could very well be a gravitational effect if it's propagating across floors.
So that was,
Yeah.
in my understanding, that's where it started. And I appreciate your bearing with me. You and I both have kind of pieces of this puzzle, and I think
Sure.
there are a lot that are just missing for everyone. But
Right.
but if we can help pull things together now, we can provide a little bit more history for folks coming into it.
Exactly. Yeah.
So in terms of Podkletnov, he did the experiment in 92. He tried to publish the paper in 96. It was leaked to the press. Apparently, he submitted this to over a dozen journals that it was rejected from. And Physics Review D, it made it through the peer review process. Someone leaked it, and it created this media firestorm. And I guess it made lots of newspaper headlines and things like that, and ended up drawing enough criticism that he withdrew the paper entirely.
Okay.
Yeah. So that's kind of where that starts out. And then let me see. Podkletnov and Ning Li were not familiar with each other's work. That's something that I am not
I
positive
believe that
about.
to be true because they preceded really. I heard about this area when I used to work for Ron Kozer, and Ron Kozer was the oversight guy, the program manager essentially for this anti-gravity program. I did not work for him at that time. I worked for him at ITT and weather satellites, and then I happened to run. That was in the mid '80s, and I happened to run into a colleague at a conference, and he says, "You're not going to believe what our old boss is working on. He's working on anti-gravity." I'm like, what? Because any other time in any other context, certainly in the '80s, if somebody said they were working on anti-gravity, it was like wah. It was going to be some nut job. It wasn't someone you really trusted and knew, a really authentic researcher like Ron Kozer. So when I heard that Ron Kozer was interested in it, that made it real for me, and so I became interested at that time.
Oh, I was going to ask that. So that's kind of what got you into it. So
Yeah.
Ron Kozer was working with Glenn Tony Robertson over at NASA, right?
Yeah. He
So,
also oversaw and funded Ning Li's effort, although it was a separate effort. He was
I
the
didn't
program manager
realize that.
for all of that for NASA. Yeah.
Okay. So yeah, that's
I
wonderful.
immediately called him when I heard what he was doing. It's like, Ron, you got to talk to me. What's going on there? And then they expanded the program when Podkletnov had his results. And I don't know how much funding they had for that. I think Tony probably was closer to that part of it.
Yeah. Well, so with Podkletnov, with his results, it did make scientific circles in terms of news. But the breakout for him was being featured in Charles Platt's Breaking the Law of Gravity that was published in Wired magazine in 1998. I remember that one. That was a giant article. It was, and I'm going to put links to all of this in the YouTube show notes.
Yeah, that'd be good to have it all together. Yeah.
Yeah, Breaking the Law of Gravity, that was a giant story. And that kind of made this front page for science enthusiasts, right? Before that, it was people who were like really into, scientific papers and things. This made it more mainstream. So Ning Li, by that time, was getting more established in her niche. And Podkletnov was really just reeling from this media blitz, I think.
Yeah, I think you're right. Then she seemed to receive some dark government funding, or at least something that they had decided it was proprietary. So she stopped publishing at that point.
Yeah. So, well, actually, she did have one more.
Okay.
Yeah. Let me see. So, and the reason I wanted to mention these two, Podkletnov and Ning Li, was they are the first two scientists, as far as I understand things, who claim to measure a change in gravitational force from superconductor
Okay.
experiments.
Yeah.
So these are kind of the two, the two paths, I guess. And
Yeah.
I believe they were both
I guess in
working
your
with
question, you
rotating.
asked, has NASA ever tested the Podkletnov effect? I thought they had. Wait, Tony was saying that they hadn't?
No, Tony said that they hadn't.
They had.
Yeah, I put that. Well, let me address that then.
Okay.
We need to put a giant pin in that for the audience, for
Right.
anyone who watches this. Um, Tony was crystal clear and repeated this like 5 times. I visited Glenn Tony Robertson at his lab
I saw
about a
something
month
about
ago.
that. Yeah.
He said NASA never replicated the Podkletnov experiment. They
Weren't able to
never
replicate it.
tested it.
Okay.
Yeah, and the other thing that he said was there are a few different experiments that were proposed. Every replication attempt did not follow the instructions. And so you have negative results. For instance, Dr. Martin Timar had negative results.
Yes, I remember
Um,
that very clearly.
a,
Yeah.
a few others did as well. They all cut corners on the experiment in one way or another.
What do you make of the claims of Amy Eskridge that there has been an experiment that has seen something? Have you seen any of that video?
So Amy talked with me about it, and I ended up talking with Claude Power, and he is in France. He's a
Okay.
scientist in France. He was somewhat tight-lipped. He was looking for funding, I believe, at the time. He said that he had replicated, I believe it was Podkletnov's impulse generator
Oh, the impulse one.
experiment,
Yeah, which is
and
slightly different than the spinning disk one. Yeah.
yeah, and saw results. Um,
Okay.
so I think that was the only one that I took away from Amy. Do you remember what she told you about experiments?
I didn't speak to her directly. I didn't know her. I only watched videos after the fact, and I believe she's passed away.
Yeah,
Yeah,
yeah.
she's no longer with us, so not possible to speak to her at this point. But there were videos of some talks that she gave. She was very organized in this area and pulled together a lot of material and presented it. And so I enjoyed watching her work. It's just that there was so little of it, unfortunately.
Yeah, so my takeaway after talking with her was Claude Power, and I believe he is
Okay.
still with us. I think he's still around. I just haven't talked to him in several years. Let me jump back to the history for a moment.
Okay.
The big story, Ning Li did have one big story that happened in the very late 90s. I think it's 2000, 2002 in that time frame. It was called Taming Gravity. It was published in Popular Science, I believe. And again, I will put a link into that. It might have been Popular Mechanics. Taming Gravity was kind of Ning Li's equivalent of the Charles Platt article. It wasn't as long, but it was certainly big, and I think that it helped to reinforce what had started with Podkletnov, because he made these giant media headlines, Wired magazine and all that.
Yeah.
Now we've got Popular Science and Mechanics covering the Ning Li doing the same thing.
Yeah.
She was talking about AC gravity there. And so the next step after that was when she left the University of Alabama to found a startup called AC Gravity. That was the name of her effect and the startup. From what I understand, she took a grant of $448,970 in 2001, but the results of that grant research were never made public.
Why?
Yeah. So she was working, again, going back to our history of this a little more, she was working with Douglas Torr and Jose Vargas at the time. She
I've
had been
forgotten
working.
Vargas was involved. Yeah, he's the theorist. He's on the theory side.
I tracked both of them down and spoke with them a couple of years ago. they said that they really lost touch with her in the very early 2000s. I
Uh,
think Jose Vargas said that it was late 90s was the last time he talked to her.
mm,
Uh, so, for folks who kind of wondered what that relationship was or where it went, um, again, Tor goes back to the beginning, back to 1991. They did about a decade's worth of work together. And then after that, it just kind of, she went her own direction, I guess.
uh,
Yeah, so I've got that. And then let me see. Glenn Tony Robertson worked with Ron Kozer on superconductor research at NASA in collaboration with Ning Li. Again, from what Tony has said, she didn't actually collaborate with NASA that much. She was working kind of alongside them. She was in Huntsville, so were they. She failed to meet several deliverables, and he claims that she withheld a lot of research, though. So
mm,
it was kind of what you might call kind of a one-way collaboration.
yeah.
Um, one of the things that Tony really stressed, and I think it's worth pointing out, is these superconductors are incredibly brittle, delicate. They're YBCO devices, right? Yttrium, barium, cupric oxide.
That's tough to work with. Yeah.
And the 12-inch devices that Podkletnov was creating are next to impossible to create. Basically, they have to sinter these. I believe they put them in a mold. They come out of the mold and break all of the time. So I don't know. Have
Yeah, I'm
you
not
had much?
familiar with that material.
Okay. So that's kind of my takeaway was one of the challenges that NASA had, that Tony had, was um, they got into trying to sinter these themselves, and they had many, many issues with breakage, cracks, deformations, things like that. And then there was another part of this that may have been related to secret sauce, which is this melt texturing on the outside of them. Yeah, and that's essentially, I believe it was putting one layer of a superconductor on top of another and then sintering, and you end up with kind of basically a bilayer device, right? Or you might think of it almost like a,
That's significant because there are certain bilayer devices. If you go from an S wave to a D wave, or vice versa, you could trigger a spin two transition, which would result in a graviton. So it could be significant. And I've looked at Giorgio Fontana's work, and looking at his work, the so-called gazer, the gravitational laser, that's how it operates. It has a dissimilar Josephson junction where there's an S type, uh,
mm,
type a type 1 attached to a type 2 D type. And then when you go through that barrier, when you push photons through that barrier, they're forcing spin 2 transitions, which are gravitons. So you're taking photon energy and you're re-emitting them as gravitons. And so that may be one of the ways that this was working versus the current zero point motion.
okay.
So
So
it
there,
could have been quantum. It could have been a quantum effect. Yeah.
so one thing I want to highlight for the audience, this has been a major point of confusion going back for 20 something years. There are at least 3 different superconductor experiments. There is Podkletnov's rotating disk, right, which again are around a 12-inch YBCO superconductive disk spinning at several thousand RPM. There's something called the impulse generator, and we'll get into that a little bit later. And then there are also high-frequency gravitational waves, and there were various proposals for that. And that's something you specialized in. You were
Yeah.
very deep
I
into
worked
that
more on the
area.
gravitational waves at the time.
So were the superconductors in that, what kind of experiments were proposed there? Did they require these massive superconductors, or was it
No,
smaller?
no. As a matter of fact, we did propose a thin film version based on Fontana's design. Fontana originally, when he published in 2007 on this, recommended a bulk design. Well, that's just a lot of material. So it's a lot easier if you can get a thin film version to work, especially if it's the transition that's forcing the gravitons anyway. All you really need is that junction, and then enough material around it that you have enough photons that are emitted or gravitons that are emitted, photons that are pushed in, gravitons that are emitted out. It's essentially a transducer type device, and you can run it in either direction, essentially. You can run it gravitons to photons or photons to gravitons. He was always working on the generator side, which is pushing photons to gravitons across that interface, essentially forcing spin 2 transitions. And so that's what he published on. And so that was certainly one technique. Another technique that Bob Baker recommended used piezoelectric crystals. And it's the mechanical motion of those crystals. And if it's the third derivative, and they have to have a quadrupole moment in order to make a gravitational wave. But you can bias them so that there's an array of these that have a quadrupole moment. If you have a third derivative of a quadrupole moment, a mechanical system can generate a gravitational wave. And that's how these black hole collisions generate gravitational waves. They have that component. That's the important component to make a gravitational wave. It's just that the effect is astronomically smaller when you're not dealing with 2 colliding black holes. So
Okay.
then the question is, can you get any mechanical device to get any meaningful level that's measurable? And then how are you going to measure it, right? So you need a detector on the other end if you're going to measure what's being emitted. And I know that Bob spent a lot of time with Fengyu Li in China working on that Lee-Baker detector scheme, which was very sensitive. It's like down to 10 to the minus 35 delta L over L, which is, parts to 10 to the minus 35 of length change was where it was measuring. The question then became, is that above or below the background noise for gravitational waves at high spectrums? We're talking about using gigahertz spectrums, which how much is naturally occurring there. So that's where the work of Leonid Grishchuk came in, because he and Rudenko had been looking at the cosmic background, trying to suggest, based on different cosmologies, how much gravitational wave background is there out there. And if it's below the 10 to the minus 35, it might still be useful as a communication device. If it's way below the natural background, it's not useful at all. So we were trying to measure, we were trying to gauge, at least, not measure, because we never built any of these devices. We're trying to gauge, would it be worthwhile to build these devices at these kinds of strain levels, which were very small.
Yeah, no, I appreciate you sharing that, because that kind of brings us to a major inflection point in the story, I think. So some of the key figures, the ones that I can remember, were definitely Drs. Robert Baker Jr., Dave Froning, Dr. Fengyu Li in China, and I believe Fengyu Li had a HFGW lab as well as grad students. He actually had a pretty big undertaking for a while. Dr. Martin Timar, and there were several others publishing papers.
George Hathaway, he has that lab in Canada, Hathaway.
Okay.
Murad Paul, even though he was like sort of the program manager for a lot of this stuff, he did a lot of work and vetted a lot of work too. So I think Murad was important. Hal Puthoff, certainly, and Eric Davis had researched this area for many years. I already mentioned Giorgio Fontana. Doug Toro we've been talking about. I just mentioned Grishchuk and Rudenko as the Russians involved in this. And then I think Clive Woods, because he was looking at the material properties from an electrical point of view of superconductors, optically and electrically. How did they behave? And how would they behave with spin 2 particles like gravitons? And so he did some work on the superconducting aspects.
No, I appreciate you listing them. That helps us to kind of collect this. Sure. So there was a major change, and I was pretty close to this in terms of time. When I got into this area, I didn't realize it then. Now it's much more apparent. Before the 2003 Mitre High-Frequency Gravitational Wave Conference, you essentially had kind of this loose collection of people. Ning Li and Podkletnov were kind of the two focus areas because of all this media attention. And then after that, you had this single event that brought everyone together, and you really had this community start to form, right? And so I did want to mention
High-Frequency Gravitational Wave Conference, yeah.
Yeah, so and that, I believe that was in McLean, Virginia, at the Mitre building.
It was. I think it was Paul Murad and Bob Baker were the co-chairs of that. And Paul Murad was a DIA guy, but he was like, we could hire a bunch of spies to spend millions of dollars to try to infiltrate their labs. or we could just invite them over. He was a pragmatist, right? We could just invite him over and, hey, what are you guys working on? And ask them that way. So I
Yes,
think
you
that
went to
latter
that one.
approach, being way more pragmatic, was quite a brilliant stroke and helped form a global community. So good,
It
good.
it, it did. It did. And there was a lot of email and online collaboration. I was like CC'd in a few of those
Yeah.
emails, and it was kind of like all of the usual suspects, and they were tossing back and forth ideas and working on
Not to say
things.
there weren't problems. The first gravitational wave conference, a bunch of the Chinese couldn't get visas because of the bird flu, and so there was that. And the second one, we got both the Russians and the Chinese all in the same room with the Americans and Europeans. But then the third one was already getting to the place where Russia wasn't cooperating with anybody, and so it was just the Chinese and the Americans at that stage.
Let me ask more about that. So the only conference that I'm aware of was the HFGW 2003 conference. These
Okay.
other two, were they the same
They were
or?
follow-ons, yeah. And so
Oh,
2007, I didn't know this at the time, was funded by HF. So this was an investigation of gravitational waves that was prompted by the behavior of UAPs. And so this early UAP task force, HF, had some money to go look at some of these areas, including gravitational waves. There was some suspicion that they were being used somehow. And so they pulled together all these experts at Hal's shop, at Hal Puthoff's shop in Austin, Texas. I think it's called Earthtech. And
Earthtech
Frank
International,
Davis
yeah.
worked there at the same time too. So I remember Eric in and out of the room, and they got us all in a skiff. And it struck me as very strange at the time. Here we are, the world superpowers all working together at the same time on the same thing. What prompted this, right? Well, what prompted it was the UAP thing, which they didn't inform us of why they were interested. All we knew was they brought us all together to work on high-frequency gravitational waves.
Okay, so
So
I wasn't aware of this conference at
yeah,
all.
there's
So
pictures. I can send you some pictures that Hal and I took, and I think Eric Davis took some pictures too. It was quite
yeah,
a nice conference. It lasted a week, just like the one in at Mitre, and they even had like a river cruise down Austin that the wives were invited to come along with us, and so Nancy got a chance to meet the Russian wives and so on. And so it was quite a pleasant conference. Hal's a very good host.
okay. So 2007 was one follow-up. You mentioned there was another one after that?
Yeah, I think it was 2017. I can look up the date. And that was hosted by the Chinese. That was in Chengdu. So they
Okay.
they had invited the Russians and Iranians, but we were starting to have a lot of conflict with the Russians, and the Russians didn't show up. And by then, Grishchuk had left Moscow, and he was working at Cardiff in England. And I think he was in poor health. He later passed away. And there's a wonderful documentary that the Ukrainians made. He's actually Ukrainian, but he was trained in Moscow right during the USSR days, because it didn't matter what republic you came from. If you were really a brilliant guy, you still got sent to Moscow. And so he quite often worked for and represented the Russians, but he was really Ukrainian. And so he didn't come, and then Rodenko didn't show up. So I think we didn't really have any Russian representation at the third one. But the
Oh,
Americans
okay.
got a lot done. Baker was there, and Andrew Beckwith was there with me. We had a fourth American scientist, and so we worked with the Chinese pretty much exclusively at that conference. Yeah, it was just the two groups.
No, I appreciate you sharing that. So
Sure.
the conferences that I am familiar with are, again, we had 2003 HFGW. That's kind of where it starts. I did not attend that one, although it is painful to have missed it, looking back in hindsight, right? I'm going to live on
Yeah,
those stories
the good
forever.
part is it was documented by Nick Cook. There was a British Jane's reporter at the time. He was covering the defense beat for Jane's, and he managed to get in the room. I don't know what strings he pulled. I think they said, "Oh, it might be classified." He's like, "Well, here's all my clearances. Any questions?"
Yeah,
So
so
they
that
were
was
able to keep
2000.
him out.
So there were also the ISNPS STAIF conferences.
Yeah, I
Uh,
started with the STAIF, and I really enjoyed those. Those were always in Albuquerque, and they were hosted by the nuclear space propulsion people. But they always had a special session for us for advanced propulsion, which I think that was very nice of them. And because since it's an internet STAIF stood for International Applications Forum, Space Technology International Applications Forum, so it was a way to get the international people in the room with the American aerospace people. And so I always appreciated the opportunity to meet with people from all over the world, at those STAIF conferences.
Yeah, and so I went to two of the STAIF conferences. I went to 2006 and 2007, and from what I understand, I could be mistaken, but the section F, which really focused on exotic
Yeah,
propulsion,
that was the advanced propulsion section.
I think that started in 2004, 2005,
Certainly,
and
I
then
remember 2005. I'd have to check my records on 2004. I may not have gone to that one.
yeah, so the ISNPS STAIF, again for the audience, that was the big space nuclear conference.
Mm.
And it had, like all of the guys from Los Alamos and Sandia, they
That's why they couldn't
basically,
have in Albuquerque, right? Yeah.
yeah, they'd
They're
let
all
them
from New
out once a
Mexico,
year and
Hawaii.
that was their conference. So,
Yep. So we just rode a line on their coattails.
yeah, and STAIF had so many brilliant topics. There was section E. I absolutely loved what they covered. And they were basically on space colonization, things like
Oh
that.
yeah, I didn't go to those at the time. Yeah.
Yeah, and then section F was all on emerging propulsion. And like you said earlier about this other conference, this was kind of a greatest hits in terms of researchers. I remember in 2006, we had pretty much all of the big names there, right? You had Dr. Martin Timar, who had made headlines repeatedly.
Right. The Austrian, yeah,
Eric Davis. I mean, yeah,
of Earthtech. Yeah.
yeah.
Well, what was the driving implication or the impediments for this in that era in the early 2000s was, of course, NASA's Breakthrough Propulsion Physics program. So this gave the BPP researchers a place to show their wares, to show their work. And so because of NASA's, I think it was uh, Mark Millis. Is that the right name?
Yeah,
Was the
yeah.
program manager for that? Because of Mark's money and his generosity for this community, we got a lot of research done under the auspices of the Breakthrough Propulsion Physics program. The Europeans, at least the Brits, felt sufficiently left out that they formed their own program at BAE Systems called Green Glow, and it wanted to do the same thing. They didn't have the same funding level, so they weren't able to get as much interest over on that side of the pond. But
I think there was also Robert Casanova at NASA, right? And I'm NASA Institute for Advanced
yeah, I
Concepts.
don't know him. Bob Chambers, I know Robert Chambers was on the British side.
Yeah,
Uh, Rob Chambers. So anyway, they also needed a venue to present, and so they were also presenting at this conference. Yeah, at the time at the STAIF conferences. So those were some of the driving emphases that led to Section F.
yeah. And then after Section F, because ISNPS closed down the STAIF conference, Glenn Tony Robertson started the SPECIF conference.
Yeah.
And I wasn't familiar with this until he sent over basically a list of all the papers he was doing reviewing on these papers. This was just as big as STAIF, except that he was taking this on. He had been a co-chair for STAIF along with Paul
Yeah,
Neurath.
it's a lot
Was
to organize a whole
he
conference, right?
yeah, he did the whole thing and he chaired SPECIF by himself. And there must have been 80 or 90 papers a year.
Yeah,
So
that's a lot to try to take on for one guy. Yeah, he
yeah,
just didn't have the same. Well, because they had University of New Mexico help support them
yeah.
on the STAIF conferences, right? So they had a whole infrastructure there, which Tony just didn't have. Yeah, so I think it only lasted a couple of years what he was doing.
Yeah, it was an amazing effort. When I learned what went into it, I was just blown away.
Yeah.
So another experiment, I mentioned this earlier, was the force beam experiment. In 2001, Eugene Podkletnov and Giovanni Modenese published a force beam paper entitled Impulse Gravity Generator Based on Charge YBCO Superconductor with Composite Crystal Structure. This was very different than Podkletnov's first experiment. People mix this up all the time, and that's why I want to clarify this. In the force beam experiment, they described a high-energy electrical discharge from a Marx generator onto a stationary superconductor. And so let me illustrate, let me highlight the differences there. Again, in the first Podkletnov experiment, you had a 12-inch diameter rotating superconductor going at several thousand RPM they claimed that it created a column of reduced gravity above it, right? In this second experiment, you had something more or less similar to a hockey puck. It was a smaller superconductor. I believe it was 4-inch diameter. And they literally just nailed this thing with a massive discharge from a Marx
Discharge.
generator.
Electrical discharge. Okay.
Yeah. Yeah. They just dropped a
Remember
ton onto
reading.
it. And there were specific parameters to it. If I remember correctly, it was inside of a magnetic field. There were definitely parameters to the distance, the voltage. I believe it was 500,000 to 1,000,000 volts. It was way up there.
I think 500,000, yeah.
Massive pulse of energy. The interesting thing, the thing that caught my eye about this, I did an interview with Podkletnov and really drilled down on this. They claimed this experiment produced a beam of gravitational force capable of crushing brick and warping 1-inch steel. So they weren't talking about, minute changes in force. They were talking about something that was, you could propel a spacecraft. Unfortunately, it probably has weapons applications, all sorts of really big picture things, right? And so that was the second experiment. People mix those two up, but they need to delineate between those two.
Yeah. Right. So I don't know if you're familiar with the work of David Maker, but he outlined at 512 kilovolts something called the vortex impulse force. So it may also have been that they were trying to hit that vortex impulse voltage because there's a natural resonance there, supposedly, in free space. I don't know that, David Maker's work is very outside the mainstream, so I don't know if that was the impetus for them to do it that way or not, but it's a funny coincidence that it's right there at 512 kilovolts.
That is interesting. And I believe that may have been the voltage, but it was way up there.
Yeah, it was way up there. We'll have to look into that.
Yeah, so I do have a couple more notables, and some of this I took a break from this area, and so some of this stuff happened kind of after I took a break from it.
Okay.
In October 2008, the Jason Defense Science Advisory Panel dismissed claims that high-frequency gravitational waves could pose any kind of national security threat. And I view this as a mixed blessing. I learned about this several years after the fact. The Jason panel, which I believe was led by Dr. Ron Pandolfi, did not cite...
It was Pandolfi requested this particular hearing of the Jasons, and so this was one of the things the Jasons touched on. Every summer, the Jasons would be handed a list of, 5 questions or half a dozen questions, and say, hey, this summer, this is what we want you to look at this. And so they convened every summer when they weren't at school, because they're all profs. And so one of the things on the list that Ron Pandolfi was highlighting was, hey, Bob Baker's off talking to the Chinese about high-frequency gravity. We should be concerned about this. And we looked at it as a scientific endeavor, not, a defense weapon development program, but they wanted to make sure, there weren't any ill effects of this work. And so is it a security threat or not? And so he got them on the list. He got HFGW on the list, specifically Bob Baker, his work. And so Bob asked, did I want to go along to the Jasons and be at the hearing? And I said, heck yeah, a free ride to San Diego. So Bonnie drove us down in the Jag. Right. Bonnie drove us down. We lived in LA both at the time. So we carpooled down to San Diego, it was at San Diego at the time. I think it travels around, or it did. It's canceled now. But at the time it was in San Diego. So we drove down to San Diego and met with them. And basically they were non-believers. They said that, all these effects are too weak to be useful. I pointed out, even weak effects can be useful for communication if it's not below the noise of the universe. And so they got hung up, I think, on the Gerstenstein effect, because I had invoked on one of my papers, not all of them, but one of them, I invoked the Gerstenstein effect as one possible technique for not only emitting gravitons, but for collecting gravitons. Basically, you say you push a graviton through a very strong magnetic field in the presence of an electric field, and out pops photons. So I don't think that's too big a stretch, and Gerstenstein had used gravitational field equations to do that, to show that. But when you work out the math, it's a very, very, very weak effect, very weak effect. if it's done with the classical field equations. In comparison with Fontana's, which is quantum mechanical, but when you're using the classical field equations, you have a very weak coupling constant of, it's g over c to the fourth or fifth, and it's astronomically small effect. So they got stuck on that, and so I think that's why they attempted to debunk based solely on the Gertrude effect. And we wrote a dissenting article later on, but I think that was just too late. And so I think that's one of the things that led to Feng Li not getting funding for his detector.
Okay. Well, and
This may have been the whole intent.
the Jason committee, to me, that seems almost like a watershed moment, because I think that it took a lot of the air out of HFGW research,
certainly.
right?
Yeah, it certainly slowed Bob down. Yeah.
Yeah, and again, so on the one hand, you had Paul Murad, who was again with Defense Intelligence. On the other hand, you had Ron Pandolfi, who was with Central Intelligence, and so this was kind of the two agencies going head to head over this
It was a bit of a tug of war, yeah. Which is a little bit of that's natural and healthy in a democracy. We don't want one agency to run everything. So, dissenting opinions, I get. I get that. I don't hold it against Ron.
Yeah. So the Jason committee did not cite Ning Li's research specifically. They did go through, I guess, more of the genre. And as you mentioned, I think that their focus was more of a concern about China's involvement in this area of research. And they were saying, can this be weaponized? The takeaway was it's far too weak to be weaponized. And that was really what the document says.
Right. That may have been the whole goal. Yeah.
They, and this is kind of the silver lining. My interpretation was that this entire branch of research could have potentially gone dark and been classified if there were applications.
Demonstrably, yes. If there's demonstrably applications that could be dangerous, yeah.
Yeah. So the Jason panel really saved this for the public. They kept it open.
I mean, we're still in the open, right?
Yeah.
Still open access literature, yeah.
So there was also a later 2010 Defense Intelligence reference document entitled The Role of Superconductors in Gravity Research.
I think there was enough work that Paul wanted to get it summarized. And everything we've discussed, by the way, is in that report. It's only like, 15 pages long, maybe tops. But it's an excellent summary of what we've just discussed. Everything, from Sakharov to Pothoff all the way through Ning Li, all the way to essentially the Jason's report was 2007. I mean, it summed up all of that work and put it in one document just for reference. So I think that's just a really valuable document. I hope you can drum up a link to it.
Absolutely.
I download it all the time. I lose it, then I download it again. I downloaded it today before we talked. But it's a really good summary.
Yeah, and it's helpful to have documents like that, because one of the things that I found is, we have these bits and pieces, right? We have the individual data points, but what we lose is the context. And that's why I'm so overjoyed to have you with me to help me just share some of the context, Yeah,
and to highlight these documents that are really still valuable and, really good, interesting historical documents,
Yeah, so in 2016, Martin Timar published Null Results of a Superconducting Gravity Impulse Generator, which described his attempt at replicating Podkletnov's experimental results without success. And it's worth pointing out that Timar had written several papers on gravitomagnetic effects, and I believe a few on high-frequency gravitational waves. So he was familiar with this area. He had gone to the STAIF conference. This was an interest area of his. From what I understand, Timar engaged his grad students, because he was a professor then, in not only this, but several other experiments as well. And because they're grad students, they did not follow the instructions as written. And so one of the challenges that he ran into was he was replicating experiments, but they weren't precise enough replications that you could rule the experiment out. And that created some tension between him and this larger community.
He did get at one point, and this is a whole series of 10 years of experiments, he got a false positive, which later he went through his instrumentation and decided it was a false positive. But it's nice of him that, when he found an error, he like announced it. So many, these experiments, because they're so highly debatable, don't get published like they should. So even a negative, a null is, still science. So I'm glad that he went through and systematically published all this material. Yeah, I remember this era, and the Aerospace Corporation was one of his funders, I believe, because Greg Mahalik at Aerospace was keenly aware of what was happening with Martin and would call me in. I was at Space Command at the time as a consultant, and so we would go through his work together, and it was very interesting work and very precise. And he was actually doing a real good systematic job. But like I say, I wound up with a null result.
Yeah, yeah. And again, that created some tension. I know a lot of people felt upset about that because they said, look, this wasn't exactly what was written on paper. But, one of the challenges in this area, though, is no matter how well written these papers are, there are always things that are kind of unknowns or X factors.
It comes down to labcraft, yeah. And they had
Yeah.
some rotation of the superfluid helium in the bottom of the vessel that was causing trouble. And so it's really hard to piece out at this level, It's university level work. I mean, this is at the cutting edge of science.
Yeah.
And so it always comes down to labcraft, yeah.
Now, again, I mentioned Claude Power earlier, and who was over in France. I spoke to him in 2020. He claimed to have replicated the Podkletnov superconductor impulse generator and saw positive results. He did
Okay.
not specify how powerful the effects were.
Okay.
Again, his focus was on a next step for this, and so he was looking for funding to kind of scale up a project. He wasn't really that interested in basically public communication unless it led to this larger project. So that was kind of where I ended up there.
Yeah, I never saw anything from, in journals. So, I mean, if I had, I would have read them. But I heard he was working in this area, but I never really saw anything come out of it.
Yeah. And then I think the final one that I have on my list here is our very own Mark Sokol from Falcon Space and the APEC conference. He attempted a public video demo of Podkletnov's force beam, again without success. So, the
I like
takeaway
a lot because it's pretty freeform. He'll throw
it is.
and he'll just keep pounding it until it works or it breaks.
Yeah. So, this superconductor timeline, and again, I appreciate your working on this with me. It helps to share this. There is so much here because you're talking about the work of dozens of people spanning 2 or 3 decades of time, right?
Yeah, it's a lot.
So,
It's been a lot. It's been fun though.
yeah. Yeah. Well, Gary, on that note, I think I should probably wrap things up for today. There's a lot that we left out, but we've given people
Yeah,
at
we'll do a
least
separate
enough.
session on your UAP stuff. Yeah.
Yeah. Okay, well, thank you again, sir, and have
Okay.
a wonderful afternoon.
All right. Thanks, Tim, for the opportunity. Most appreciated.